So midterm problems, these 15 questions. The first problem is a parameter population sample, parameter statistics. The what you look for here is the parameter is the whole group. Okay, so keywords right here like all. That is what you are looking for. So on this one, they have to talk about the total of all the TVs is right there. But when you have the sample, they're just doing a random sample of 600. That is the sample. They don't say the word sample there, but a random selection of 600 TVs. That is part of the group. Okay, so this is something that happens. Now I won't go off on too many tangents because I don't want my iPad to die, but this is why some TVs are more expensive than other TVs. It's called quantitative analysis, but Sony or whatever expensive brand may check all their TVs or 50% of their TVs, whereas HCL, Vizio, whatever may only check 10% of their TVs to see. So they do a random selection here. So the population is all the whole group samples part of it. Now the other thing to remember here is population goes with the parameter, and a statistic goes with the sample. P and P, S and S. Statistic. Why did I just go blank there? Statistic. So P and P, population parameter. This is a prediction. A parameter is a prediction. Okay. So the 6 TVs are the random selection of 800 or the selection of 600. That tells me that's coming from the sample. So that is the statistic. The average retail price of the 450 of the random selection of 600 TVs. That tells me that's part of the sample. That's statistic. The 2.3% of all the TVs. That tells me that's going to be a parameter of the TVs December to the month of March. Okay. So most of the time we don't have the total amount. What we are trying to do is take that sample and predict the total amount there. And that is why it is a prediction or a parameter. A statistic is something that we actually know for sure from our sample. Number 2 is on the test work page. So this one is reading a chart. You got 50 players. This one, the key to this one, and I can't generate new questions when I look at it like this. This one just says show your work on the test work page. But the key to this one is less than 1900. Less than 1900, so less than 1900 to be anything less than. So you would add up these numbers. I know I kept saying the key to this one 8 times now, but what is that, 56, 78? Okay. What you have to be careful of on this one is this is relative frequency, which means it's already a percent. Okay? If it says frequency, that's just a number, so you'll have to divide. You have to divide by the total. This is why I tell you to do this multiple times, so that you kind of see the different iterations. You'll know this because the frequency would be more it'd be 7 or 8, 12, 13. It'd be numbers like that instead of decimals. So what you have to do is to find the proportion of that, you would have to divide. On this one, I don't have to divide because they're already percentages. So on the test work page, it says show your work on that. So all you have to do is kind of write what we had right there. I kind of did that. What is it, 10, 12, 28, 28? So I just want something like that, like what I wrote there. 10 plus 12 plus 28 plus 28 equals 0.78. Okay, that one shouldn't be hard to do on the test work page. Just show your work on that. You are welcome to use the back of this page for any other work you want. So you can write more than what they asked for, but I want to see at least that. Number 3, you build a frequency histogram, frequency distribution. I'm doing this. I'm drawing it out. Cheating. I think it's easier to draw it out than it is to do it on the computer. So there are 16 cyclists. That's nice to know because you want to know the total amount, so my n equals 16. So between 0.5 and 4.5, 1, 2, 3, 4, 5. Okay. Between 4.5 and 8.5, 1, 2, 3. 8.5 and 12.5, 1, 2, 3, 4. 12.5 to 16.5, 1, 2, 17 and 18, 2. The reason it's nice to know the total amount is because now you can add these up and check your answer. So that helps to make sure you got them all when you're doing it on the computer. And then you just draw the graph. 5, 3, 4, 2, 2. Okay. I don't remember if this one does relative frequency or not. But if it's relative frequency, again, you have to divide. You're going to have to divide by the total. Like if it asks for the relative frequency, then it wants a percentage or a proportion. So I can't remember, honestly, if that one changes or not. I know the other one changes, but I'm not for sure about that one. On this one, it is comparing the mean and the range. The mean has to do with the center of the data. The range has to do with the variability. So my keywords here are the variability. That's going to deal with the range. So which one has the most variability would be the range of 49 right there, class A. And then you know that the average is the same thing as the mean. Which one has the lowest mean is C. Don't miss the easy ones, right? Number 5, again, has to do with the mean and the range. This is the center versus the spread. So these right here are the center, the measures of center. And these over here are the measures of spread. Okay. So when I look at this, it says select the best description for the spread. I am looking at the range in the IQR. It needs to tell me something true about the range in the IQR. We can tell by the range that the books read is 8. That is true. The other ones are not true. The smallest and largest, we don't know anything about that. The median, the median has to do with the center, so we're not going to look at that. This one's talking about the center, so it's going to be something about the mean and the median. We see that a typical student read about 31 books. I don't know where they're getting 31 from. Oh, she asked her 31 students. We see a typical student read about 11 or 12 books. I like that because both my numbers are 11 and 12 right here, right? So that sounds good to me. The other one is read about 7 to 8 books, okay? So the main thing there is identifying that center has something to do with mean and median, and the spread has something to do with the range and the IQR. For this last one, on this problem, to be symmetric, it means perfectly symmetric, so the mean has to equal the median. I know these are close, 11 and 12, but they are not perfect, okay? It has to equal the median. Not close, it has to actually equal it. We would say this is approximately symmetric because 11 and 12. But on this problem specifically, they have to equal each other to be symmetric. 11 does not equal 12, so it's not symmetric. Percentile, this is on our test work page, but percentile is always less than or equal to that amount. So government agencies keep data about the income distribution of the population. The Coleman family and Pham family live in a county with 9,000 families. The Coleman family income is at 16th percentile, and the Pham's family income is at the 88th percentile. Which of the following is true about the Colemans? The Coleman family earns more than about 84% of the families. Now, where are they getting 84 from? That would say 100 minus 16 is 84. But what this means is I need to go to my test work page, but I don't want to leave this yet. So I'll say this and then we'll go write it down. The two ways to interpret this is that 16% of the families earn less than the Coleman, or 84% earn more than the Colemans. Okay, so you could say it's always the percentile always gives you the less than, but if you do 100 minus that number, it would give you the more than. So about 84% of the families in the county earn more. I like that one. The Coleman family earns about 16% of the highest income in the country. No, the 16% highest would mean that'd be the 84th percentile, because 84 would be lower. The Coleman family earns about the 84th of the highest income of the county. Sorry, I'm trying to figure out why that one's wrong. Oh. Anybody remember from doing this problem? I don't have the answers either. About 84% of the families in the county earn more than the Coleman family. The Coleman family earns about 84% of the highest. 84% of the highest income. Okay, so if the highest income is $1 million, that's saying 84% times $1 million. That's talking about comparing 84% of the highest income. Okay, sorry. The percentile always has the data amount. I was reading that wrong the first time I read it. So yeah, it has nothing to do with the percentage of their income compared to the highest. So we were right. Okay. Which of the following must be true about the Coleman's family and the Phams family? The Pham family earns more than the Coleman's family. That is true. You can compare because Pham is 88 and Coleman is 16, right? So you know that they earn more than that because that number is bigger. They both earn more than the median. No, Coleman doesn't earn more than the median. The Pham family earns 72. We have no idea how much they earn. We just know where it falls in the county. The Coleman and family both have an income in the bottom half. Not true because Pham would be in the top half because they're above 50%. So for our test work page, I forgot number 5. Why didn't y'all tell me number 5? Number 5 is over here to the right. The measures of center are the mean and median. See, this is something you get as soon as you get your paper. You could write this down, and that helps you do that problem. So the measures of the center are the mean and the median. The measures of the spread are the range and IQR. And that's all I really want there is to say like what those go with. So I talked about it. I just didn't write it on the paper. And then on this one, we would say 16% of county, you can paraphrase, earn less than Coleman. 84% of county earn more than Coleman. Something like that. It's harder for me because I can't jump back and forth. You'll be able to see. But I'm looking for that these numbers add up to 100% and one says less and one says more. Okay. All right. Number 7 is also on the test work page. What's the test work page say? What are the 5 numbers and their percentiles for the box and whiskers? Okay, so the 5 numbers are the minimum, the first quartile, the median, the third quartile, and the maximum. Their percentiles are 0, 25, 50, 75, 100, right? If you have the highest test score, 100% of people scored lower than you. The IQR is Q3 minus Q1. I'd be okay if you wrote that. It is also the middle 50%. You don't have to write all of these. I'm just giving you ideas. Middle 50%. It could also be how wide the box is. That's real non-mathematical, but that is what it is. It's how wide the box is on a box and whiskers. How far is it from the 75th percentile to the 25th? So really any of those would work, as long as you had something like that on there. What's our next one? Our next one's number 8. My goodness, I put a lot at the beginning here. Okay, so to actually do this problem, what is the median? The median is the middle number. That is the number inside the box. So my median is right here. It is 31. What is the largest number? The largest number is your maximum. It's right here. It is 41. And then what is the third quartile? The third quartile is the edge of the box. 35. Okay. So that one shouldn't be too bad. Again, the IQR, I don't think they asked this, but it's 35 minus 26. It would be 9. So my first quartile is 26, so 35 minus 26 would be 9. The interquartile range is just a single number. Number 8 is on the test work page too. I do not believe we need to see the problem for this one. So this is a correlation problem. As x increases, y increases when it's positive. That creates, as I go to the right, I'm also going up. That creates a positive shape. On negative, as x is increasing, y is decreasing. Because as I go to the right, my graph is going down. Okay? So all you really got to do is circle it. Positive, increase, increase. Negative is increase, decrease. Now we don't have to go back to that till number 15. So on this one, for these 25 students, as the time spent watching TV increases, the time spent doing homework decreases. You know those are going to be opposite because it's negative. For these 24 students, there is a negative correlation. It's going down from left to right, so it's negative. Using line of best fit, we would predict that a student watching 12 hours of TV would do approximately, for homework for approximately what? I'll screenshot it so we can write on it real quick. So 12 hours of TV would be right here, right? 12 hours, go up to the line, not a dot, go to the line, and that would be 18. 18 hours of homework. So 17.5, maybe it was just below. So pick the closest number there. It goes down from left to right. That's how we know it's negative. And then since it's negative, we know it increase, decrease. Come on. No, just go. On this one, might have to go like this. I know it's a little harder for y'all to see, but this one is talking about the shape of the graph or the association, what kind of association each of these have. The closer it is to a line, the closer it is to 1 or -1. Okay, so like this one I can't tell, right? I can't tell if it's going up or down, so it's going to be close to 0. This one you can clearly see that it's going up, right? So it's going to be positive. I don't know, it could be like around 0.75 or something like that. Okay, it's pretty strong. It's probably even a little stronger than that. It's probably like 0.85. This one is clearly going down, so it's negative. It would be something like 0.85. And then this one is going up. It does have an up, but it's pretty weak, right? It's pretty weak, so we would say something like, you can clearly tell it's going up, so it's probably like 0.5, something like that. So which one has the strongest positive? Strongest positive, I would say UV, right? UV, this one. That one's clearly positive. It is obviously stronger than this one. Which one has the one closest to 0? That would be XY, because you can't tell whether it's positive or negative. Which one has the one closest to -1? Well, there's only one negative, and that's WT. Which data set has one equal to 1? Equal to 1, this is actually none. Because to be equal to 1, it would have to be a straight line. It would have to be a perfectly straight line. That's the only time this would be like R equals 1. So it has to be a straight line for it to be equal to 1. Come on, don't do that weird thing with the continue bar down there. Man, which one are we on, 10? Still gonna do it. I need to see that problem. Oh, there it's in the middle. Okay. Wait, I need the equation. Oh, I covered it up, didn't it? Come on. My goodness. Why is it not? I can't read the question. Eight. There we go. I'll just do it this way. All right, so this one, when you're doing it on the homework, I know it says some formulas and stuff, but you do not have to do anything crazy here. You have the observed versus the predicted. The observed is an actual value that you found. So observed comes from the table. So 3.14, that's my observed. My observed is 6.59. That's someone actually had a campaign cost of 3.14, so we know exactly what they sent. That's an actual statistic. Like more of a parameter here is when we do what is the predicted, okay? So we are going to use this formula and plug it in. So what would we predict if someone spent 3.14? We would do 0.19 times 3.14. We would plug that in to my X. 3.14 times 0.19 plus 6.12 is 6.7166. Okay, so you use the equation, which is using the line when you predict. What is it? 3.14 would be, we're using like this point right here on the line. Whereas with the observed, we actually have a number right here, and it would be this one right here. Okay, so this one is the observed because we actually found that data, and then we use the line to predict. They will switch up if A is observed or predict, and then B is observed or predict, so be careful there. All right, number 11 is a permutation combination problem. I know that because you have a total amount and you're choosing some of that from there, okay? So permutation, the order matters. Combination, the order does not matter. A certain Committee consists of 18 people. We want a president, vice president, secretary, treasurer. How many ways can these 4 offices be filled? The order does matter on this because president is better than vice president, is better than secretary, treasurer, and treasurer. So I'm going to do permutation 18, permutation 4. 18 permutation 4. So that is 73440. Somebody remember that for me. 73440. The next one, 13 albums released by a musician. The recording company wishes to release 8 of them in a box set. Does it matter what order they come in? Not really. So we do combination because the order doesn't matter. 12, 8, 7. What did I say this one was? 12, 8, 7. Order does not matter. Anybody remember that other number for me?
73440.
So 18P4, order matters. Oh my goodness, we gonna make it with my iPad dying? I guess I can always pull up the computer and work the rest of it, but oh, we're on 12. Some probability problems here. Maya works in an IT company for a local company. There are 100 computers on a computer's network. 16 of them are infected with a virus. Oh, this should be an easy problem for you. Don't miss the easy ones. A is the computer that is infected with a virus. What's the probability she randomly picks one and it has a virus? This would be 16 out of 100. Okay. 0.16. B is it does not infected with a virus. So the way you find that is 100 minus 16 is 84. So there's 84 out of 100 that do not have. Those are the same numbers as percentile, but if 16% have viruses, then 84 of them do not. Number 13, a deck of cards. I think all of these will have this, but do be careful whether they replace it or not. As in, suppose a card is drawn at random from deck, then the card is shuffled back in, okay? I think all of them are shuffled back in, but I'm not 100% sure. So this has, they call it replacement, okay? My total is not going to change. And the second card is drawn at random from the card and then shuffled back into the deck. Finally, a third time the card is drawn and shuffled back into the deck. What's the probability that the first is drawing a 3? Okay, so a 3, there are 4 of them, right? So that'd be 4 out of 52 total. Just do one at a time. So this is a 3, right? For the next one, a face card. So a face card would be all of these. There are 12 of those. So it'd be 12. We put the card back in so it stays at 52. And then the last one is a spade. So the spade would be all of these. There are 13 of those. So that'd be 13 out of 52. We put the card back in so our total does not change. If we take the card out, if we took the first card out, then there's only 51. We take that card out, then there's only 50. Okay. I'm not 100% sure which test problem I chose here, so be careful with that. So 4 times 12 times 13 divided by 52 divided by 52 divided by 52. Should be about 0.0044. You do multiply these. I did not say that. But think about them individually and then multiply them. Just go one at a time when you're trying to figure out the probability for each one. Number 14 is a probability problem where you're reading the graph. All right, so I always like to, when I do this problem, is go ahead and get my totals amount. So this is 30, this is 25, this is 20, this is 25, and those both add up to be 30. Okay, so what is the probability that the probability of a vaccine would be 12 plus 18. So that would be 18 out of 50. The dog in the vaccine would just be this number, right? That would be 12 out of 50. There's the hard part. What's the probability that the dog, given that they have a vaccine? Since it says given that they have a vaccine, the only thing you're doing is looking at this row. Okay? At this row for part C. All right. So now, what's the problem? So I know they have a vaccine. Like, I know the animal has a vaccine. So what's the probability I pick a dog out of those animals that have a vaccine? That would be 12 out of 30. Okay? Because I'm only looking at that row. So whatever this second one is right here, you only look at that row or that column. Y'all remember that a little bit?
Professor,
Yes.
wouldn't A be like 30 out of 50?
A would be 30 out of 50. I didn't add correctly. My bad. 30 out of 50, right? 12 plus 18 is 30. 30 out of 50 have the vaccine. Yes. My bad. I'm trying to go fast before my iPad dies. We can keep working problems if you want to. I just want to finish my video before. All right, the last one is a hard one because it is binomial. The manufacturer of a fertilizer guarantees that with the aid of the fertilizer, 75% of the planted seeds will germinate. Suppose the manufacturer is correct. If 7 seeds planted with the fertilizer are randomly selected, what's the probability that fewer than 5 of them? The way you know it's binomial is really that fewer than 5. Anytime it says something like that you're trying to find like less than 5 or greater than 5 or anything like that, it is binomial. I'm going to go ahead and put this in the calculator so I can get my answer, and then I'll come back and explain it. So I can screenshot it real quick. 0.75 fewer than 5 would be less than or equal to 4. 0.244. Okay, the way that I recommend doing this is there are 7 total, right? So the 7 total right here, kind of cut that off a little bit, but come on, let me circle that. 7 total. I want fewer than 5. Fewer than 5 would be these, right? So that is why I put less than or equal to 4 in the calculator. Okay. Now I don't remember my answer. Anybody remember it? 0.24 what? 244? I think it was 0.244. We'll double check it. But you can use this button in the calculator. This button is you do N then P less than or equal to X is the way that works. What you have to be careful of on this one is if it is greater than or equal to. Okay, so on the work page, you would come over here and say, you just write what you put in the calculator. We put 0.75 less than or equal to 4. I know, you're fixing to die. I got it. Just to make sure that we understand those, because those do generate several different ways, okay? So let's try to do one more of those. That is the tricky one on the test. It is only one problem, but not that one. Okay, so this one right here, just to do another one. Employment rate of a city is 14%. If 8 people are randomly selected, what's the probability you find more than 2? So again, 0, 1, 2, 3, 4, 5, 6, 7, 8. So more than 2. More than 2 would be I want 3, 4, 5, 6, 7, 8, right? But I cannot put the greater than in the calculator. So what I'm going to do is put, I'm going to put 2 in the calculator, And then to flip that sign, I do 1 minus that number. And that flips it over, okay? So that just tells me that if this is 20%, then this has to be 80%, okay? So be careful with those. I always do just write it out 0 to your last number and then circle what you want. And if your circle's on the right side, then you got to do 1 minus. Circle's on the left side, you just plug it in. All right.